Welcome everyone to the Introduction to Electronics for Robotics talk. This talk will serve as the first lecture to the Introduction to Robotics CTE. So I guess if you've attended the previous lectures, you might be familiar that the work we do in ERC can be categorized into three broad verticals: mechanical design, automation and software, and lastly electronics. Uh, you all might know, you might have studied theoretical electronics as part of high school physics, but how exactly do you implement them in real life? How do you use them to make real life gadgets and robotics? This is what I'm going to talk about in today's talk. I will be explaining the kind of work we do under electronics in ERC's projects and how you can learn and make such projects yourself. So, the main areas that we work in under electronics are the following. Analog electronics deals with systems that involve continuous signals. This is in contrast with digital electronics, where the signals are interpreted as either zeros or ones. In digital electronics, uh, we deal with logic plus ones or zeros, and we deal with gates. You must have heard of AND or AND and OR gates. But most importantly, in digital electronics, we deal with microcontroller programming. And lastly, we have PCB design. So if you've opened up an electronic device, you might have seen that green circuit board. These printed circuit boards are very reliable and a foolproof way of connecting several electronic components together. So if you want to take your design or project beyond the prototyping stage, it's advised to create a custom PCB using PCB designing softwares. More on all these areas later. So for the first domain, we have analog electronics. As I said, these are systems that involve continuous signals as opposed to ones and zeros that you encounter in digital electronics. Uh, Wherever we have sensors or audio or radio, analog electronics often comes up. For example, in the middle image, you can see a photoresistor or light-dependent resistor whose resistance varies proportionally with the amount of light falling upon it. This is an example of an analog sensor. Another example is the sound card in um, this is the sound card in your PC, which converts a digital audio file into analog audio that can drive the magnets in your loudspeakers. So operation amplifiers, you might have heard of these. These are like fundamental tools used in analog electronics. They're not just used for amplifying signals, but also for carrying out various mathematical operations on signals. For example, you can configure them to differentiate or integrate a time varying signal, or you can compare one signal with another signal. You also have filters. For example, on the bottom right, you have a resistor capacitor low pass filter. What this does is basically allow the lower frequency components of a signal to pass through while reducing the amplitude of the high frequency components. We also have several other kinds of filters like high pass filters or band pass filters, which are a combination of both. More advanced topics include Fourier and Laplace transforms. The Fourier transform in particular is very widely used throughout electronics. What it basically does is to convert a time domain signal, or it converts a signal into its individual frequency components. More on that later, or you'll come to know about that later on. Now, I'd like to take the heart rate monitor as a kind of case study for analog electronics. So how the heart rate monitor works is by they have several conductive pads placed on your body which measure the resistance. And as your heart pumps blood, the resistance changes ever so slightly. This change in resistance is then converted into a change in voltage by using Ohm's law, V is equal to IR, and it's amplified probably using an operation amplifier. And before it is recorded, a lot of this is a very sensitive signal, so we have to filter out all the noise. So we usually have a filter which removes the 50 hertz noise which is picked up from our mains electronics. And finally, this analog signal is converted into a digital signal using an analog to digital converter. Moving on to the next area, microcontroller programming. So microcontrollers are a computer etched onto a single chip. Unlike the microprocessor, like the Intel microprocessor you might have in your PC, microcontrollers not only have the CPU, but they also have program memory, RAM, input-output pins, and other peripherals, like, for example, analog to digital converters. The most commonly used or well-known example is the Arduino board, pictured on the right. You might have seen these, like we use them very commonly in our projects because they're so easy to use. I'll show you how exactly we might use them. This is the simplest example, blinking an LED. First, we open our Integrated Development Environment, or IDE, on our computer. This is a program where we can write and compile our code. So we write this code. The code shown on the left is very simple. It just blinks an LED with a time period of 2 seconds. And you write this code, you compile it, wherein the IDE will convert your code into binary. And this code is then transferred to your Arduino board, and it runs this program as shown on the right. Of course, you can run much more complicated programs and involve several LEDs or several sensors or in fact anything you want really. Coming back to our same example, the heart rate monitor. So once we have recorded our signal, what can we do with it? So we have recorded the signal as in a digital form. We now have a graph, a time like y versus t graph of the signal. And what we can do is use an algorithm which we can write in C and use that algorithm to count the number of heartbeats per minute and calculate the beats per minute. This is done by writing a program in C and uploading it to the microcontroller, just as I've shown previously. Now, coming to the tools we commonly use in electronics, the breadboard is the bread and butter of electronics really. It's a fundamental tool which we use for prototyping, and without it, I don't think we'll be able to do anything really. So, what is this breadboard? Uh, you might see these. They just look like a kind of plastic device which has several holes, and we can insert components like resistors or capacitors. We can insert wires into these holes, and you can't see them, but underneath, hidden beneath the plastic, the holes are connected in a predictable fashion. For example, each row or holes in each row is connected to each other. So if you connect one component, if you connect two components in a single row, they will become electrically connected. So instead of having to solder two wires together or having to precariously twist two wires together and all of that, you can simply use a breadboard, which is extremely convenient for large circuits like the one on the right. Without a breadboard, you'd have to probably solder them together or take the two wires and twist them together. This is very unreliable, very messy and untidy and prone to errors. So it's best to use a breadboard. You might say we can also make a circuit board, but Making and fabricating a circuit board can be time consuming and expensive. So for prototyping, breadboards are a favorite tool. Of course, if you want to finalize your project, it is recommended that you make a customized printed circuit board or PCB. We commonly use softwares like Autodesk EagleCAD or KiCad. KiCad is a free open source version, and Autodesk has EagleCAD, which is a paid version, but as Bitsians, we have access to it. You can download it for free using your Bits email. And on the left is a screenshot of a printed circuit board design, specifically an Arduino board. Like we can design an Arduino board on our own also. And you can see, we have to make the connections ourselves. And after making the connections, we can send it to a PCB fabrication plant, or we can send it to a PCB fab plant, and they can produce the printed circuit boards for us. Or if you're feeling ambitious, you can even make the printed circuit boards yourself using several fabrication methods, including CNCs or CNCs or yeah. Now there are also other areas which I haven't touched upon and which we don't use very commonly because they are more complex, and one of them is FPGAs and programmable logic in general. So what are FPGAs? Um, so if you're familiar with logic gates, they they have an input based like in zeros and ones, and they have an output. And in FPGAs, you don't just make a sequence of instructions. You program the circuit itself. You can actually program a logic circuit from scratch in FPGAs. And the one pictured here, like the statics FPGA, is used by engineers at NVIDIA or Intel or AMD. They're used to prototype their processors. So like if you if they're developing the new Intel series, for example, like the 12th gen, they will first implement it in an FPGA, because in an FPGA the circuit isn't set in hardware. They can be programmed and debugged and so on. Now another field is radio electronics, and this is a very advanced field, and I would say, and even many electronics engineers consider it black magic. So we don't really delve much into it because anyway we have access to a lot of off-the-shelf components and protocols which take care of the nitty-gritty details, and you might uh, be more aware of it or come across it in your third or fourth year if you're an electronics student. But usually, like the one picture on the right, we can just buy them and use them very easily because they take care of the most complicated parts of radio electronics. So, of course, a common question amongst a lot of you, especially firsties, are how do I start, and how do I start making projects, and how, most importantly, how do I join the electronics and robotics club? So, we would recommend that you take help from us through the Intro to Robotics CTE. We will cover a lot of topics, not just in electronics, but also uh, controls and some mech design. And another thing we plan to roll out in the next week actually are mini projects. So these will be open projects, anyone can join, and we will guide you and mentor you with a project goal. And we'll help you along the way to learn the things necessary. And for the most part, you need no prerequisites, although knowing a programming language is a strong is a good preference. We'll also have, and even if you don't have like basic knowledge to a programming language or to electronics, we will have mini workshops where For example, we'll teach you how to use or how to program Arduino. And you don't even need any hardware for these. You don't need to buy an Arduino board. You don't need to buy any breadboard or anything, because we'll be using an online circuit simulator called Tinkercad. Tinkercad allows you to design circuits, connect circuits, and even program Arduinos on software. Like, it's entirely simulated. You don't even need to download anything. It's an online based simulator. So most of our workshops will be obviously done online, and other workshops will include MATLAB, Python, and they're all tentative, and we'll let you know the dates hopefully by next week. Of course, if you want help or if you want to do it yourself, we recommend the QSTP Mechatronics material. So QSTP, where basically these are the Quark Summer Technical Projects, and we took the Mechatronics course last summer in 2020, and we made the electronics material, I mean all the material from scratch, aimed at absolute beginners. And you don't even need any hardware, as again, all of these examples in the material can be done in Tinkercad. And if you do have hardware at your disposal, or if you are willing to buy hardware, then you can try out Jeremy Blum's tutorials on YouTube. And hopefully there will be a link in the description, or someone from ERC will post a link on the live chat. And of course, this is very important. If you want to do anything, like not just electronics, but also automation or mechanical design, I really urge you to learn a programming language. If you're into electronics, then start learning C, because Arduino is coded in C++, but a knowledge of C is also good enough. So hopefully I've covered everything. And if you have any questions, then please go ahead and ask them on the live chat, or you could also ask them on our Discord. So I'm going to wait for the questions. Okay, it seems our members covered most questions, and yeah, just to, in case people have this question, this is a recurring question. Uh, is ERC holding inductions? And the answer to this is no. Unlike other clubs, we are not having straightforward inductions where you just write some answers or give an interview. Instead, we have a different process. So you can get inducted into ERC through several channels. You can join the CTE and complete it with a good, completion is good enough for inductions. You can also join our mini projects, which we will announce hopefully by next week or the coming week. You can join the mini projects and make some valuable contributions, by which we will definitely induct you. You can also attend most of our workshops, and towards after these workshops, by Feb or March, we will release assignments and challenges. And if you show a good performance in those, we will definitely induct you through that also. And am I missing any other rule? Of course, if you show us some of your old projects, and if you engage in our discussions, then also we might consider you for inductions. So there's no specific date for inductions. We will induct people as and when they complete or achieve these goals. Someone asked, when we design Arduino or PCB, how do we print it? do we have a PCB printer in bits? So either we can send them to a PCB manufacturer, or in bits we have a tool called a PCB mill. So I don't know if you know what a mill, a CNC mill is in general, but basically this machine can, like you feed it the PCB design and it etches the PCB for you. Like you have a blank PCB template which you get from electronic supplier, and it will kind of etch out the copper traces which is required for the PCB. So yes, we do have a PCB mill in bits, and also we can use several other, I would say, jugaad methods to make PCBs, like the famous laser printer method, or the toner transfer method actually, where we print the design on using a laser printer and we use an iron to imprint it on a PCB and then etch it using chemicals. That's a long method, but that is something I have definitely used at home. So you actually don't need very expensive equipment for simple PCBs. So for queries on the CTE, Vedant will answer them on the live chat. Okay, so if there are no further questions, we will now, we will move on to the next part, wherein uh, where Vedant will go into the details of the Intro to Robotics CTE, and he'll talk you through the handout and what we're going to do about the code. So if you have any questions about the CTE, just hold them for now. Hopefully Vedant will answer them.
Tanmay, should I start?
Yeah, yeah.
Cool. So, hey guys. Okay, so just to clear some confusion, we chose to stream the class today on YouTube because we also had the final lecture of our introductory robotics series, that was Introduction to Electronics. So just for clarification, this part is being streamed live as well. You can choose either to stay on the meet and watch it over here or stream on YouTube. I'll be taking all the course related questions at the end. You could ask the questions using the live chat on YouTube the or our Discord server. Someone from ERC would probably put the link to Discord server on the live chat. Cool. So let's start. All right. So this course is being conducted by the Electronics and Robotics Club, as you might know. So we've been conducting this course for a long time, as long back as when CT first started conducting courses. So this is one of the oldest courses. So in today's presentation, we'll go for I'll first introduce you to the instructors and mentors for the course. Then I'll move on to what we aim to achieve through this course, the basic learning outcomes that you should expect. Then we'll move on to timeline of the course and the course content, where we'll have a brief look at the handout and what all things you're going to learn. Then we'll move on to evaluations and the course project, and I'll take questions at the end. Okay, so the team of instructors include me. I'm Vedant Shah, and I'm the teaching head of ERC. The other instructors include Mohit Chaudhary, Aditya Bidwa, and Advait Kulkarni. All of these are core members of ERC, and all of these are third year students. As we go over the handout, you'll notice that there are a lot of different things that we're going to do, which is why each one of us is specialized, is an expert in their own field. The mentors will be Ashutosh Gupta and Pranav Goyal. Both are the media head of ERC and are second year students. All right. So what you should expect from this course is that we want you to get familiarized with the basic tools and techniques, and the most commonly used softwares that are used for making a basic functioning robot. So there's a lot of things that go into making a robot, such as you need to decide what the hardware would be. So I think, as Tanmay mentioned in the previous session, we have microcontrollers and microprocessors that basically control how the entire robot runs. I know that most of you would have heard these terms in context of smartphones or computers, but these are not just limited to those. Even a robot requires a brain entity where it does all its computing, and so this is where processing units or processors come into picture. Then we'll also be covering how to program that hardware. So as Tanmay mentioned, if we take the case of a simple Arduino board, it's just hardware, but to actually make it work, you need to program it. So for example, Arduino is programmed using C and C++, and some other commonly used programming languages with respect to robotics development is Python, and a few more. But yeah, mostly we'll be covering Python and C++. The next part of building a robot is the mechanical design, which is the actual body of the robot, the joints of the robot, actuators of the robot, what all types of motors are being used. This part will also include the CAD designing part, which we notice that a lot of you are interested in. And the final part is, robotics is just not something, an experimental thing. There's also a lot of theory that goes into making a robot work. When a robot is going from one place to another, you need to do all the calculations. Obviously those calculations are done by the computing unit, but you also need to deploy certain algorithm. For example, if I tell a robot to pick up a particular thing and place it, it's not just going to do it without a lot of commands that are being given to it. So that consists of the mathematics part, which will mainly be control theory. Now, going over the course timeline, we'll start with Introduction to Electronics, which we already did. This was the lecture one. Now, from the next lecture, we'll be starting with how to program a basic Arduino board. So the second lecture will be on, you'll be introduced to basic C programming, since it's very essential. And like the Arduino board is programmed using C language. Further, we'll be looking at some more advanced embedded systems and PCB designing concepts. So now some of you might ask what an embedded system is. So whenever you see any kind of hardware shouldered onto something or embedded onto something, it consists of an embedded system. So a robot also has its basic circuitry, right? The electronics part of the robot. So there's an entire embedded system that goes into the working of a robot. Then we'll have a couple of lectures on the mechanical aspect of a robot. We'll cover different types of wheels, different types of gears, different types of joints and actuators, and finally the CAD designing part, where we'll be using software such as SolidWorks and Fusion 360. We'll also be having a small workshop, like I think a lecture, uh, a 2-hour lecture, or a couple of lectures on PCB designing using Eagle, which is a very widely used industrial software for making circuits. Then we'll move on to control theory and kinematics. So basically, the part forward further from here consists of the automation part of the robotics. First, we had the electronics part, then we did the mechanical part, and now we'll be doing the automation part. So what automation means is basically you're telling a robot to do something and it does it on its own. For example, you're saying a robot to go from path A to path B, and it's planning, mapping the path on its own and then going to point B. We'll obviously not be diving into that much detail, since that area is basically covered in our intermediate robotics course, which is usually conducted in the second semester. But yeah, we'll be establishing the basic mathematical principles that you need to, write these algorithms. Uh, then we'll be introducing you to basic Python and ROS. ROS is Robot Operating System, which is basically one of the core frameworks used for robotic automation. And yeah, it's a really cool thing. You can even check it out if you're already familiar with Python. And the last lecture will be giving you an overview of how artificial intelligence is being used in robotics nowadays. Things like computer vision, reinforcement learning, and then there's this whole new field of open source robotics, where people from all over the world are working on many things on the same thing using open source software. Okay, now so let's go over the handout. As I said, this was the first demo lecture on introduction to electronics. The next couple of lectures, you'll be doing C programming, basics of C programming. You'll be getting familiarized with some basic C++ syntax, and then we'll move on to development boards, with the focus being on Arduino. So Arduino is known as a development board, or a microcontroller. So whenever the blue thing that you saw in Tanmay's slides was the entire Arduino board, and it has a small chip and a black chip embedded in between, which is known as a microcontroller. So a development board, the difference between a microcontroller and a development board is that the development board has a lot of input output ports, which basically makes it easy for us to connect it with different things. Whenever you need to use a microcontroller, you'll need to solder it on some kind of board and then solder wires to it, which kind of is inconvenient for low end projects. And so yeah, there are you if you're interested, you can check out other development boards such as Raspberry Pi and ESP32. We'll actually be using ESP32 in this course also for the final projects. Okay, so once we're done with Arduino basics, we'll move on to some more advanced concepts in embedded systems such as PCB designing and interfacing sensors with Arduino. Or there are a lot of other things. For example, we have LED screens, we have servo motors that we can interface with Arduino. So this is all the basic electronics part. From lecture 9th, we'll be doing mechanical design, and as I mentioned before, we'll be introducing you to some basic mechanical components that go into building the physical robot, and we'll also be doing CAD designing. Then we'll have a couple of lectures on control theory and kinematics. So here you'll be using the softwares MATLAB and Simulink. MATLAB is a very widely used software, not just for robotics, for literally everything. You can do machine learning on it, you can do reinforcement learning on it, you can do signal processing on it. So yeah, it's a very useful skill to have. So a lot of things that are mentioned here you might not be understanding, like you don't know what control theory is, or you don't know what a PID controller is, but you don't really need to worry about that, since we'll be teaching everything from scratch. And yeah, by the way, there are no prerequisites that you need to attend this course. It's absolute. Even if you are a complete noob, you don't even know C or Python, it's completely fine, since we'll be covering that too. Yeah, so we'll be trying to cover the kinematics section. So kinematics, I think most of you know what kinematics is. You've done it in your plus one, plus two, but kinematics in robotics is not as simple as what you used to do in your 11th and 12th, right? So we'll be trying to demonstrate how kinematics is used in a robotics setting with a use case, for example, a robot arm. This is not fixed yet, but yeah. Yeah, then we'll be going on to Python, have a couple of lectures on introductory Python and the basic syntax. And then the 18th, this is where things get really interesting, at least for me. So we'll be covering Linux basics. Linux is, as you know, an operating system, and it is one of the most widely used operating, and also one of the most convenient operating systems for robotic development, or just development in general. You'll see even Android developers or web developers or machine learning engineers using Linux more frequently than Windows. uh, like there is a certain reason behind it, which is like it's very extremely compatible with all the open source software, and whatever you need to do the development. So we'll be covering, so you might have heard of the terminal, the Linux terminal, which is basically something like the command line that you have in Windows. So we'll be teaching you some basic commands in that, and how to and like how to write a basic bash script. uh, yeah, then we'll have a couple of lectures on robot operating system. We won't be going in too much detail of this, because we have an entire course on it, and it's not even possible to cover the entire robot ROS on in a couple of lectures, or even in an entire course. It's a very useful, but also very complicated software. So it has a lot of use cases. And yeah, so the last lecture we will be looking at how artificial intelligence has helped robotics develop. So the last lecture we won't be teaching anything technical, but it will be just an overview lecture for you to get some motivation. So right now, so this is just a tentative plan, but in for evaluation we plan to have occasional weekly assignments. So we have around 21 lectures at the end of each week. Might not be every week, but whenever we accomplished a basic topic, we'll probably release an implementation based assignment. For example, at the end of first week or the second week, when you become familiar with Arduino basics, or how to program Arduino to accomplish a simple task like blink an LED, or control a servo motor. We'll give some basic implementation based assignments, and the weightage of each assignment would be 10% of the final course total. And then you'll have a final course project, which will not be as simple as a weekly assignment, but way more interesting than it, and you'll definitely enjoy doing it. uh, we haven't finalized whether we'll have just a single course project or two course projects, but let's see. And so our plans currently are that hopefully by the time we get to the end of course, we might be on campus already, hopefully. And so in that case, we'll be providing you with the ESP boards. ESP is just another microcontroller like Arduino, but it has a lot of other features, such as it has Wi-Fi and you can attach Bluetooth modules to it, etc, etc. So yeah, it's a really interesting thing. Plus, It can also be programmed with Arduino IDE, which you'll be learning for Arduino anyway. And so depending on how many assignments we give out, the course project will carry about 20 or 30% weightage of the total of the course total. So we haven't announced the course project, but yeah, you'll be using my ESP32 microcontroller. So like to get an idea of what kind of projects we usually give, here are some examples from previous years. So this is the first one is a line following robot, which basically you can see a black line over here, right? With the just a sec. Okay. So as you can see, the robot is following this black line. Now you may think that this that you might be confused as of what use this is of, or this is very simple. At least it looks very simple, but trust me, it's not. There's a lot of engineering that goes into making one of these. We also have a line following robot competition at Quark, which is our technical fest, and not just at Quark, at most of the technical fest. I think at the IIT Bombay's Tech Fest also has a line following robot competition. And yeah, one of our members, Mohit, actually, he's also one of the instructors. He made a line following bot in his first year itself and stood first in the competition which was conducted in Quark. Then another project that we had was the obstacle avoiding robot. So this robot basically just detects the obstacles and moves back. So as you can see, it's moving forward, and then whenever it encounters this furniture, it is just or a person's leg, it is just stopping or changing its direction of movement. uh yeah, so you don't need to worry about most of the times you don't need to worry about the actual chassis or the body of the robot, because we have pre-made, for smaller robots. These are small DIY kind of project thingies. So for smaller robots, you usually get a kit and you have this chassis inbuilt with it. So all you need to do is fit the sensors, screw the sensors to it, screw the motors to it, and write the basic code, and you're good to go. But obviously, at DRC, we have projects which are much more complicated than this and much more advanced than this. You might have seen some of those in our previous lecture series, such as we have had Trodbot, we have Modbots, which are really cool projects. Yeah, so if you need some motivation to take this course or perform well in it, is that if you perform good and end up among the top scorers, you'll get a chance to get inducted into ERC directly. The second one is that we can't guarantee this, but if we get enough participation, if we retain enough participation, and if we have, if someone performs well enough, you'll have your CTE course fees that you're paying for registering into this course. That is, I think it's an amount of 500 rupees. You'll be refunded that. So yeah, this was all about the course that we'll be conducting this sem. But what can you expect to go into or look into once you know all this? So we have usually after the course in the semester after the semester in which we conduct the course, we conduct another course called Intermediate Robotics, where we work with more advanced stuff. And so where we cover topics like robot operating system. So we'll be covering ROS in this course as well, but it will be a very introductory kind of thing. Then you can learn to work with actual robot simulations. So we'll be using a simulator this sem, but that will be for simulating the Arduino board. But when you're working with simulators like Gazebo or Ignition, you can actually simulate entire robots and test your algorithms on them, which is pretty cool. We'll be doing some amount of motion planning, and then path planning or navigation, which is as I described earlier. You give a robot a starting point and an ending point, and the robot will on its own map the entire path from point A to point B. And then we have things like computer vision and reinforcement learning in robotics, which is basically artificial intelligence. Yeah, so I'll be taking any questions that you have now. You can either ask the questions on the Meet chat or YouTube live stream or the Discord server. So yeah, I noticed that some of you were asking some queries related to the course when Tanmay's session ended. So you can ask them now. Okay, so one question I see is, are we needed to register in courses for next classes from CT website or ERC? What will be the frequency? All right. So you will be needed to register on the CT website. The website URL is CTBPGC. Oh, just a sec. Um, yeah, it's bpgc-ct.org. Where you can go and register for our course. The frequency of classes is for the first week, that is for the current week when we're having the demo lectures. We'll be having 3 demo lectures this week itself. So one is today, the another one will be on Wednesday, and the last demo lecture will be on Friday. So these lectures are basically for you to decide whether you are actually interested in this kind of stuff, and if you are, you can register right now. If you are not and you have already registered, you can deregister before Friday or before the fourth class, which I think will be in next week. um Okay, can you give one difference between a PCB and an Arduino? All right, so okay, this is a pretty good question. So PCB is something. Okay, Arduino is also a sort of PCB since you have a lot of components embedded on the board, but it's Arduino is something which is manufactured and ready to use. When you're doing PCB, what you usually have is a special PCB board. Then you mark where all you'll place the components. For example, I'll place a chip or a microcontroller in the sensor and in the center, and resistor at some distance away from it. Then what you can do is you can engrave certain parts on it, and when you engrave, the entire PCB board is made up of copper. Sorry, it has a layer of copper in between. So whenever you engrave a path from one terminal of the chip to an Arduino, the both of those get connected. So Arduino is also a kind of PCB, but we usually use the term PCB for something we've made on your own. So if you have a basic circuit, you could just make it on a PCB. Does this course happen next sem as well? So usually what happens is during semester one, that is the period from July to August to December, we have this course during that period, and in the second semester, during this time, January to May, we have the intermediate robotics course. So, but this year, unfortunately, due to Corona, this course was delayed, and so the timeline has shifted a bit. We aren't exactly sure what we'll be doing next semester. So if the next batch joins soon, that is during August session, we'll probably conduct this course. But yeah, I can't say anything as of now. Nothing is decided. Do we have to learn Git before contributing to many? Okay, so let me make this one thing very clear. You don't need to learn anything before starting on mini projects, right? Probably having a basic knowledge of C++ or C or Python would be good, but everything that you need from for doing the project, you can learn when after you start working on the project itself. Usually that's how projects work, right? Because you don't know, whenever you're starting with a project, you don't know what are things you'll require to what are skills, or what are softwares, or what are things you require to work on it. You don't know it immediately, but as and when you start working on a robot, on a project, you gradually get a hang of what all you require, and you can learn parallelly as and when you're doing the project. But okay, so since we'll be doing mini projects in a remote setting, that is, we can't work on anything physically, it will probably be a good idea to learn Git, because then you can push all your code to GitHub, and So this can also act as a record that you did the project. And there are a lot of open source programs that look at, or even when you're sitting for interviews or something, when your profile is being evaluated, people do look at GitHub profiles if you've kept a record of your projects. Is it allowed to certain? Yeah, definitely. You can skip certain lectures if you're you know, already familiar with the concept. But if you do skip, try to just take 5 or 10 minutes after the lecture to go through the recording to see if anything extra was taught. The resources shared in roadmap, are we supposed to know all that before the lecture starts, or will you cover that too? You aren't supposed. So many of the things mentioned in the roadmap will also be taught in this course. So you don't need to start doing, if you are taking this course, that is, if you are taking this course, it's okay if you don't start doing it on your own. But yeah, there's nothing stopping you if you are extra curious and want to start doing things ahead of the timeline. The resources are just supplementary material, which is like other places where you can refer to get a better idea of what all has already been taught in the course. Will that be any team activities? Yeah, so the final project that you'll be doing will be a group based project, which you'll be forming groups of 3 or 4 people, where you'll be doing uh, and where you'll be working together on the final project. Okay, so let me make one thing very clear. ERC will be conducting some mini projects, and which are an entirely different thing from CT projects. By entirely different thing, I don't mean that I mean the difficulty level of the two projects will be different, but the mini projects that we at ERC will be conducting don't have anything to do with the final CT project. uh, which languages we must learn for future benefits as well as for robotics. So you should probably start with C++. Actually, start with Python, and once you're comfortable enough with Python, you can move on to C or C++. But so if you are in computer science, or even if you are taught C language in the second semester, so it's probably advisable to go through basic Python and then start with C or C++. Or you can do it either way around. I mean, both is fine because both languages are very widely used. Okay, I think give a clear difference between CT course and mini projects and what ERC will do. Okay, so I think I already covered this, but I'll go over this once again. So ERC is a club which will be conducting CT course, and ERC will also be conducting some mini projects. Now, as a part of the CT course, we will also have a final project, which are two completely different things. I hope the difference is clear. Frequency of lectures will have 3 lectures for this week and then 2 lectures per week moving ahead. But the lectures we miss, no, it won't affect your chances of inductions. See, it's completely fine to skip lectures if you're already familiar with the aspect. But as I said that try to last through the lectures once you get the recording, so that you make sure that we didn't teach anything extra that you didn't know. But class participation will be really appreciated, and we'll be also looking at your performance in the evaluation components. So you don't need to stress over the evaluation components. We aren't we are also students, right? We aren't your professors who will be strictly grading on your evaluation components. Okay, I forgot to mention one thing. We'll even be conducting doubt solving sessions uh, from time to time if we feel like a particular concept is a bit difficult for you to grasp. So, and the timings for them will be arranged with taking everyone's convenience into account. Uh, but yeah, all we are looking for is some active participation. Even for the assignments that we give, we will release solutions after the submission deadline. So you don't need to worry about that. But yeah, all we're looking for is some active participation and interest. When will the workshops happen? Okay, so our plan as of now is that Some we can convert some of the CT lectures as workshops. For example, I told you that the PCB designing lecture, we might take it as a workshop. By workshop, what we mean is that we'll be conducting a single lecture of, a longer duration, which is like 3 hours or something, and you'll probably be doing a lot of hands-on stuff on that. So that is our idea of workshops. So this is just one example, but we might have another. For example, when we are doing CAD design or something, we also might. So you might have noticed that we've taken two classes or three, only three classes for mechanical design. So it might not be possible to cover everything from mechanical design as well as CAD modeling in just three classes. So in that case, we might convert the third class to a workshop, which will be, a 3 hour thing, to a 3 hour long class in which we'll be demonstrating how you can use the software. So yeah, and these workshops would be open for all, not just for people who are registered in CTE. Yeah, so one important thing is that you make like, don't assume this to be don't take this as a normal coursework that you are doing at as a part of your academics. This is something extracurricular that you're interested in and you're doing, which will probably help you as you go ahead with your academics as well. For example, if you're an electronics students, you have a lot of courses on embedded systems further. So some things that you learn here might help you get a better understanding of these courses. So yeah. Okay, are there any other questions? I think I've already overshooted my time. So I'll wait for like a couple of more minutes if there are any other questions, and then we'll end the session. Mm, yep. So that is the end. Thank you everyone for attending the first demo lecture. The second demo lecture is on Wednesday at the same time. We might not conduct it on live stream. We'll probably be using the Meet link which CT has provided. So yeah, thank you.